Hello everyone, welcome back to the science class. So in this video, in this part 3, it's a part 3 of the series chemical equations and reactions, chapter 1, science of class 10th. So in the last videos I had told you about the different indicators which indicate that a reaction has taken place. For example, I'll just go through I'll just go through all the indicators once again. So one of them was change in color. I'll just write it down. So change in color. This was the most common indicator. Okay, change in color. It means that the reactants will have a different color, and when the product gets formed, it will have a different color. Okay, formation of a precipitate. Obviously, as I gave it the example of barium sulfate yesterday, in the last video. So, barium sulfate forms a white color PPT. Okay, I'll just write PPT, precipitate. Okay, I'll just revise what a precipitate is. That an insoluble product. Okay, precipitate is an insoluble product which either insoluble means it does not dissolve in the solution. It does not dissolve in the solution. Okay, so that is why it is called insoluble. You can see the precipitate either settled down after the reaction has taken place or floating on the top. Okay, it will appear as a different layer altogether. So it will not be dissolved in the solution. That is why it is an insoluble, semi-solid product, you can say. Okay, semi-solid is also a very important characteristic of a precipitate. Okay, I'll just write here. Example was barium sulfate. Okay. All right. Then third one is evolution of a gas. Like in this example only, along with barium sulfate, hydrogen gas is released, right? So that is also one of the examples. So evolution of a gas, okay, it could produce a sound just like hydrogen, or it could also produce a smell like ammonia. Okay, so we can also say, like, I can just write down here, sound could be one, like in case of hydrogen, or smell. Okay, so it depends what kind of gas is released. Depending on that particular thing will happen, whether a sound is getting produced or a smell. You can smell something. Okay, so these are the three indicators. Along with this, fourth one, change in temperature, is also one of the important indicators. Change in temperature. Sometimes the products when the reaction has taken place, the products might have a higher temperature. The test tube or a beaker in which you perform the reaction, okay, whether it is a test tube or it's a beaker, which in whatever you perform the reaction, you'll notice a change in temperature. Either it will the reactants which were at room temperature initially or before the reaction, they either, after the reaction has taken place, either the temperature will drop below the room temperature, or it will rise above the room temperature. It can go both ways. It can either be like this was, suppose, the room temperature RT. Okay, it can either go up, okay, or it can either go down. So it depends on what kind of a reaction has taken place. Okay, so this is also one of the important things. Along with that, another important characteristic is change in physical state. This also I explained in the last video. I told you that first of all, while writing a chemical equation, we always mention about the physical states of the reactants and the products, right? So in that case, if the reactant was barium, in this, which was a solid initially, it reacts with HCl, which was aqueous. I told you what aqueous means. That is, if pure HCl is not used, we use HCl solution. That is, it could be 50-40 or 50-50, or it could be 60-40, it could be 80-20, like that. Like 80% HCl, pure HCl, and 20% water. So basically, it's a solution in water. It is not a pure liquid. That is why we are writing aqueous or AQ. Okay, and this gives barium sulfate plus hydrogen. Okay, so sorry, I've written HCl actually, so it will be barium chloride here. Or either I'll just write H2SO4 here. It will be better. Just write H2SO4. Okay, so the equation is also balanced. So here barium sulfate is a PPT. So you can see the change of, and this hydrogen is a gas. You can see that there is a clear change in the physical state. In the case of reactants, barium was solid and H2SO4 was aqueous. And when the reaction took place, barium sulfate, which was a product, was a precipitate. It was neither a solid nor a liquid. It was a semi-solid thing. And hydrogen was a gas. So you can see that there is a clear change of physical states. Solid and aqueous have changed to PPT, that is precipitate, and gas, right? So there is a clear change in physical state, and it is also one of the very important indicators of a reaction. So I hope all this was clear. I just wanted to go through it once before we proceed. Okay, so in the next part of the chapter, we'll be discussing about the types of reactions, basically. Okay, so in case of types of reactions, I'll just write reactions like this. Okay, so types of reactions, one of which we had discussed yesterday itself. If I say A plus B, I mean in the part 1, I gave an example of a very common reaction, that is Na plus Cl gives NaCl, right? So this is a very common example. And so what is basically happening in this reaction? I said that there are two atoms, one of sodium and another of chlorine, which are combining together, or they are coming close together. Okay, just suppose this is a sodium atom, and say for example this is the chlorine atom. So right now they are separate. Okay, they are separate. I'll just write a plus sign here. Okay, so what will happen now when they are coming close together? As I told in part 1 video, that if sodium atom is in one room and chlorine atom is in another room, they have to come into the same room to hold hands together and to form a bond, right? So that they can form this molecule, that is sodium chloride. Okay, or NaCl. This is one entity, and these are two separate atoms, and this is one entity, basically one molecule. Now here we can't say that sodium and chlorine are different atoms. They have combined together, they have bonded together. Okay, it will look something like this. If this is sodium, for example, and this is chlorine. So it looks something like this. Okay, and if I magnify, you can see a very small black bond. I just try to create a bond here. If it's visible, I don't know, like this basically. Okay, this black colored thing you can see here. So this is a bond. This is showing a bond. Usually we do not show a bond, but just to explain that sodium and chlorine have joined hands to form this sodium chloride. Okay, this was Na and this was Cl. So what is basically happening, that both of them had to come close together and they were combining, right? They were combining together to form one product, right? So this is a kind of combination reaction. Okay, I'll just write NaCl here. This is a kind of combination reaction. Now, what does the word combination mean? As I said, coming close together. Combination simply means coming close together in this case. I'll give a very simple analogy, or you can say a very simple एक और example in daily life. Okay, for example, you must have gone to shops and you must have seen that there are products which come in combos. You must have heard this word combo. Okay, now combo is basically in case of dishes. If you go to a restaurant, you order something and it says that you will get a combo of, say, suppose South Indian food. Okay, South Indian just may you see idli, vada, dosa and all that. So either you can buy idli separately, okay, and either or you can buy a combo which has idlis also, dosa also and vada also, everything. So it's a South Indian combo. Means it's a combination of all these three dishes together. You're getting all these three together on one plate. Okay, whereas in case of if I buy idli separately, if I buy vada separately, I'll be getting them in different plates and not on one plate. You're getting my point. Basically, when two or three things are coming together, okay, they're forming a combination to form one product. In this case, the important thing to note is that the product is only one. Basically, it's one entity. Okay, as we saw in sodium chloride case entity. Okay, as in so there could be basically more than one more than one element, A plus B plus C. Okay, they combine together to form ABC. Now here, in case of these are the reactants, right? Now A plus B plus C, these are three separate entities. Okay, and ABC is one entity. That was what I was trying to explain in the last example also, that Na and Cl are two separate entities. Entity is basically items. You can think of entity as an item. Okay, they're two separate items, and when they combine together, they form one item or one entity. Okay, it could be A plus B plus C, it could be A plus B, which forms AB, as in case of NaCl. Here, AB is one entity, they're not separate. Okay, it's one entity or one item. Okay, so these have joined together to form this one item. Okay, here there are two separate items or entities. It could be A plus B plus C plus D. It could be n number of reactants, but eventually they form one product only. So this is one item. They have joined together to form one item. Here there are four separate items. Just to clarify that the number of reactants could be any. It could be n number of reactants. But eventually they will come together, they will join together to form just one item, one product. So this is what we call as combination. Okay, they are coming together to join and form one particular product. This is a very important thing to note. One entity or one product is formed. Okay, from two or more reactants. At least there will be two, right? Reactants have to be two. At least दो तो होंगे तभी तो combination होगा, right? So at least two, like from two or more. It could be 3, it could be 4, it could be 10 also. It could be any number of reactants, but eventually just one product will be formed. And this is what we call as a combination reaction. So this is one type of reaction. We'll study about the other types in the next video. Thank you. Hope you enjoyed it.